Whoa, I'm not ready for proofs yet. I'm not ready for proofs yet. If you have to look back in your notes, look back in your notes. One way to prove triangles similar. One method of proving triangles similar. Oh, started off 4. Side angle side. And make sure we have the tilde with it, right? Because that means I'm proving triangles similar versus congruent. Another method. 5. How about we just relax on that third A? All right, relax there, tough guy. All right, thank you. And 8.
Side.
And again, make sure we put the tilde so we know we're proving them similar. All right, today we're going to go back to statements and reasons and prove 2 triangles similar. So those are our 3 ways, but I have good news for you. When you're doing a statements reasons, only one makes sense out of those 3. From Friday, if you chose to use side, 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 that didn't mean the sides were congruent. That meant what about the sides? What did we know about the sides of 2 triangles if I chose to use side, side, side? Not that they were congruent, but what? They're in the same proportion. And to figure out if they're in the same proportion, wouldn't I need to know the side lengths? Wouldn't I need to know the side lengths to see if they're in proportion? And I want you to now think about every statements and reasons proof we've done this year. Hundreds, probably, hundreds. How many of those proofs in the diagram did I give you how long the sides were? Anybody remember? I can't. 0. What am I trying to tell you here? There's no way you're going to use side, side, side in a statement's reasons, because I'm not going to give you the lengths. Also, what else probably can't be used then? Side angle side. What am I trying to get at here? When we do a statement's reasons proving triangles similar, there's only going to be one way, and that is angle, angle. Can you find 2 pairs of angles congruent? That's the way it's going to be. Because I can't, guys. I can't use these 2 methods unless I know the side lengths. And I'm never giving you the side lengths. So this is the only way we're going when proving triangles similar in a statement's reasons. I gave you guys a nice and easy one to start off. Prove these 2 triangles similar if WR and VB are parallel. Hey, so we already know only angle, angle. So what's your job? Find me 2 pairs of angles congruent and you're good. Find me 2 pairs. I'm not even going to let you do this in your group. This should be too easy. Too easy for you. 21, give me a pair of angles. Why? Darn right they are. One pair of angles down. Need another pair. Don't even do this to me. Come on. We've done this all year long. Don't do this to me. You know where they are. 5. Come on, Greg. I'll just say W and B. W congruent to B. Or you could say R and V are congruent. Why, Greg? No, you didn't. Don't. Yeah, thank your group for that. Parallel lines imply alternate interior angles congruent. And guess what? We're done. That's all. Angle, angle. Angle, angle. Let's write the statement. Triangle WSR similar to triangle BSV. Angle, angle. Whoa. Check your statement. Do you have the similar symbol or do you have congruent? Come on now, come on. Okay, there's a part B. There's a part B, which is not part of the proof. This is an algebra question now. All right, this is an algebra question, part B. Now I'll give you side lengths. What's the missing side? And that's what you can discuss in your group for about a minute. SB 10, WS 15, SV is 20. How about side RS now? They're similar, so their sides are in proportion. Come up with a good proportion in your group. Go ahead, about a minute. Which sides match up, right? Which sides match up in each triangle? You got it. You got it.
20 over. No, it's x over 20. X over 20. Wait. Oh, did I do that wrong? Wait. No, you're right. Wait. WS. No, WS is 15. Sorry, I wrote that wrong. X over 15. No, it's 15, 20. X over 15. Is equal to 20 over 10. Yeah. I did that right. Yeah.
But no, when you put the.
Nope. Wait.
Do 15 over 10 equals. I just looked at it.
Oh.
15 over 10 equals x over 20.
All right, give me a good proportion you guys came up with. 17, go ahead. What's your proportion?
I got
Let's go. First one ever, Tammy, that I called on. Somebody was home and they actually answered. Great job.
15 out of 10 equals x over 20.
Good work. I like it. How you feeling at home? All right? You doing all right? Everybody good? Questions here? Are we comfortable matching up the 15 and the 10 and the x and the 20 that they had to match up? Again? Hey, here's my cheat code again. Remember, W was congruent to B, so the sides across match up. That's what I mean. All right? By my little cheat code. W and B were equal, so the sides across matched up. And then we all should have got what for this side? X equals 30. Questions, comments? Hey! Everyone's like, yo, this is simple, easy, angle, angle. Sometimes though, that one of the A's might be hard to find. Let's talk about that then. When one of the A's is a little hard to find. Oh, a little rectangle action. Missed you, rectangle. And I got two perpendicular lines, AQ, BD. Hey, watch yourself here. Look at the triangles we're trying to prove similar. BAD and BEA, which is kind of overlapping inside of BAD. So be careful. Watch yourself there. Watch yourself. So at least recognize the two triangles first. Recognize them. Now you know it's going to be angle, angle. It's just, can we find them? Can we find angles that would be congruent? Using the givens or something we may see all by ourselves. Anybody see anything here? Anything? Oh, hi, Lauren.
Hi.
How are you?
I'm great. How are you?
Unbelievable. Go ahead.
BA is a right angle.
BA?
BEA.
Oh, BEA. All right, let me start there. Yes. BEA is a right angle. How do you know?
Perpendicular lines form right angles.
And notice I'm not going to put the other right angle in here because it's a right angle for a different reason than perpendicular lines form right angles. All right, that is a right angle. Now the other right angle, which is located somewhere in the big triangle, is a right angle for a different reason. Where is that right angle first? In the big triangle, where's that other right angle? Hi, Meg.
Angle DAB.
Good job. Angle DAB is a right angle. This bad boy right here is a right angle. Not because of perpendicular lines. How did Meg know that was a right angle? It's a rectangle. Well, obviously you know what it was. Rectangle implies all right angles. Right? That's what a rectangle is. It's got all right angles. I still got to say, what about the two right angles, though? I still don't have A. Darn right, I got to make them congruent so I can get one A out of angle, angle. Angle BEA congruent to angle DAB. All right angles congruent. All right, we're getting there. Remember I said sometimes one A would be easy, the other A, an angle might be tough. Where's the other angle? Because you guys really exhausted all the givens. You used it, so this might be something you got to find on your own. Anybody see anything else? Any other angles? Griff, yeah, you do.
Angle DBA is compared to angle DBA.
Angle that is in both. Good job, young buck. Right here. Everyone see that angle contained in both? Angle DBA congruent to itself. Good job. So sometimes it might be a little tricky. Reflexive, and then the triangles are similar. Yeah. Triangle BAD, similar to triangle BEA. Angle. Everyone okay? Enjoy those proofs because they get 1 step longer tomorrow, 2 steps longer on Wednesday. Enjoy the angle while you can. All right, I'm done. I can't, we don't need to do more proofs of angle. You guys pick it up. You just got to find 2 angles. What I really want to focus on is writing these proportions and solving them. All right, go ahead. Set up your triangles for me. Set them up. Set up this one anyway. This will probably be the last one we'll be able to do. Okay, real quickly, before we start doing a lot of hardcore Algebra 1. Some of you, I don't know if anybody's wondering why they gave us the lines are parallel. You guys remember what type of angles those are? Corresponding, so they're congruent. And same thing over here, right? They're doing that because now the small triangle and the big one are what? If I have these 2 pairs of angles right now, what do I know about the small one and the big one? They are similar. And did I tell you that in the directions? No. So that's how you get them similar, so you can set that up. Okay, because they're not in a proportion until they're similar. So that's why they're similar. Okay, let me get rid of all this here. Okay. We see 2 triangles, right? We see the 2 triangles. Now we got to match up the sides. Give me 2 sides from the small triangle. That's how I start mine out. Give me 2 sides from the small triangle. 9, 2 sides from the small triangle. And, okay, x over 1. Now here comes the tough part. Matching up the sides. Remember, Friday, full sides only. No partial sides, full sides only. Okay, question for everybody. Let me start with x, which is AE. Don't tell me the length, just tell me the name. Name the side that would match up to AE in my big triangle. AE and what other side match up? AC. Everyone agrees? AE and AC. Now it's your job. How long is AC? Combine your like terms. Don't multiply, add them. How long is AC right now? 2x plus 2. Everyone all right? That's how long AC is. Next, what does AD match up with now? This side of 1, what does it match? Just name it first. AD and what other side match up? AB. So how long is AB? So I can put it in the proportion. How do you write how long AB would be? 1 plus x. I'm just going to flip it because I like the x's to come first. X plus 1. Are we all right there? You got to add to see the total length. Add, not multiply. Add to see the total length. All right, you know where we're going here? In your groups. Go ahead. This is cross multiply. You're going to end up factoring probably, so I'll let you guys take it over. This was just like the homework problem that nobody had a question on. Go ahead, cross multiply. I'll do my work up here and hopefully we match at the end. Remember, no factoring unless it's equal to 0. You better have it equal to 0 before you start saying numbers that do this and add to this. Keep distributing, Charlotte. X squared, but then you forgot to distribute it to the 1. Okay? So x squared plus. When you get it equal to 0, we should have x squared minus x minus 2. Get it equal, and that's what you're looking to factor right now. Go ahead, keep going, we got time. 2 numbers that multiply to this and add to this. And then we end up with x minus 2 and x plus 1. When you factor 2 numbers that multiply to -2 but add to -1. Any issues? Equal to 0. You guys know from here. X equals 2. X equals -1. Let's have this awkward staring contest until somebody tells me we got a problem. Hi, Jonathan.
X being -1 wouldn't work.
Why?
It would make some of the sides negative.
Yeah, look, if I take -1 and plug it into DB or AE, you're going to get a negative side. Not going to happen. So make sure, make sure we reject that answer. My last question before we call it a day here. What would you need to use if you couldn't factor tonight? Like, say you couldn't find 2 numbers that multiply to this and add to this. What do you have to go to next? Quadratic formula. Okay, so don't be surprised if you have to go to quadratic formula tonight too. Great job today. We'll slow it down a little bit tomorrow with more time. Thursday quiz, everyone. Thursday quiz.